Artificial intelligence algorithms are now capable of flying fighter jets and even perform fighting maneuvers. Yes, you heard that right. The UK is now the latest of a couple of nations that is spending big money on these developments. An eye-watering £10 billion is allocated towards the development of autonomous fighter jets. But what is this buzz all about, and will this leave pilots with their feet on the ground in the future? Let's have a look. The British, Japanese, and Italian forces are joined to work on some of the most sophisticated technology as of this date. By 2035, the Global Combat Air Program is intended to deliver the world's most advanced combat aircraft, which is capable of solely being flown by lines of code. Of course, the US has been working on this for several years already, and recent tests have shown the technology to be quite advanced already. The US has successfully tested an AI fighter jet, which took over the flight in midair. Over the course of a short test flight, the fighter jet engaged in advanced fighter maneuver drills, including simulated aerial dogfights, before landing successfully back at the test site. The usage of semi-autonomous and autonomous drones has come into rapid developments due to the effectiveness that can be seen in the Ukraine war. The US has been testing different kinds of AI algorithms during the course of the last 20 years, but it's now more relevant than ever. US U-2 spy planes and a successful autonomous test flight in a Black Hawk helicopter are two of the most recent examples, next to the Revolutech 6.2i fighter jet tests. To focus a bit more on what is going on in these developments, let's have a look at the Revolutech 6.2i tests recently. VISTA stands for Variable in-Flight Simulation Test Aircraft. This algorithm got a much-needed update just recently, which incorporates a model-following algorithm and a system for autonomous control of simulations. These changes, combined with the VISTA simulation system, facilitate an emphasis on autonomy and AI integration, needed for reliable autonomous flights. Additional components include integration of advanced sensors, a multi-level security solution, and a set of GETIC tablet displays in both cockpits. These components enhance VISTA's capabilities while maintaining its rapid prototyping advantage, specifically allowing for quick software changes to increase the frequency of flight test flights and accelerating the pace of AI and autonomy development to meet urgent national security needs. The Department of Defense stresses that all systems are designed to supplement human pilots, not replace them. In some instances, AI co-pilot systems could act as a support mechanism for pilots in active combat. These systems are capable of parsing millions of data inputs per second and having the ability to take control of the plane at critical junctures. This could be vital in life or death situations. For more routine missions that do not require human input, flights could be entirely autonomous, with the nose section of planes being swapped out when a cockpit is not required for a human pilot. An official of the program states that they are not trying to replace pilots, but merely try to augment them, give them an extra tool to work with. They view it as historic horse-riding soldiers riding into battle. The horses and the humans had to work together intensively. A horse rides the trail really well, so the soldier had to worry less on how to get from point A to B. He just stepped on his horse and rode off. By leveraging these systems, pilots with 100 flight hours can artificially gain the exact same edge as a much higher-ranking officer with more than 1,000 flight hours. All thanks to AI augmentation. Incorporating AI is a logical outgrowth of the work that Bill Gray, top test pilot at the USAF Test Pilot School, does with human learners. Whenever pilots discuss the difficulties of training and qualifying AI agents with engineers and scientists, they typically treat this as a new problem, he says. This concerns me because I have spent decades teaching and certifying extremely nonlinear and unpredictable natural intelligence agents, which is a fancy term for students. The issue for me isn't, can we educate and certify AI agents? Why can we train and qualify people? And what can this tell us about training and qualifying AI agents? Gray thinks that AI is not a magic tool that can solve all of the problems, but that it must be created in a balanced manner, with built-in safety measures to avoid costly mishaps. Gray thinks that an over-reliance on AI, which would result into a trust in the autonomy, can be hazardous, citing failures in Tesla's automation program despite Tesla's assertion that the driver must remain at the wheel as a fallback. This shows that, although AI has came a long way, it still is an extension of humans, despite what many news articles make you believe. The U.S. Air Force is working extremely hard on overhauling their current systems to adapt to new threats and lessen the response times. The engineering speed is unrivaled as well. The engineers and developers of these systems can push code on 7:30 in the morning, and it will be operational and ready to test at 10. Algorithms are changed and onboarded within minutes. Although this great success might indicate this is taking off within months, but we are far from that. These things tend to take time, but as the future of warfare is autonomous, it seems like the right development. The US, China, and now Japan, the UK, and Italy are betting heavily on this technology. If you like this video, please drop a like and consider subscribing to stay on top of the latest developments. See you all in the next video.